Circuits, a wire path that allows change to flow.
Electric charge exists due to excess or deficient electrons on an object. Charge comes in two kinds, positive and negative. The unit of the charge is coulomb. Electric current is the flow of positive charge per second. The unit of currents are amperes. 1 ampere means 1 coulomb of charge flowing per second. Resistance measured in ohms tells how difficult it is for charge to flow through a circuit element. Resistivity is a property of material which implies what the resistance would be of a matter. Voltage is electrical potential energy per coulomb of charge.
Ohm's law states that voltage across a circuit element equals that element's current times its resistance. The junction rule states that the current entering a wire junction equals the current leaving the junction. The loop rule states that the sum of voltage changes around a circuit loop is 0.
There are two types of circuits, series and parallel. Series resistors each carry the same current, which is equal to the total current through the series combination. The voltage across series resistors is different for each, but adds to the total voltage across the series combination.
In a series circuit, each device is connected in a manner such there is only one pathway by which charge can traverse the external circuit. Each charge passing through the loop of the external circuit will pass through each resistor in a consecutive fashion. Basically, it is that the charge is going through one pathway from which the charge can pass through the external circuit. All the charges will pass through each resistor in a continuous fashion.
When the path for a current divides, then comes immediately back together, the resistors are connected in the parallel. The voltage across parallel resistors is the same for each and equal to the total voltage across the parallel combination. Parallel resistors each carry different currents, which add to the total current through the parallel combination. A parallel circuit has two or more paths for current to flow through. The sum of the currents through each path is equal to the total current that flows from the source. As you can see, when you add another bulb, the light becomes dimmer. This is because each bulb has the same voltage and shares the current.
Power. Electrical circuits are all about energy. Energy is put into a circuit by the battery or the commercial electricity supplier. The elements of the circuit, lights, heaters, motors, refrigerators, and even wires, convert this electric potential energy into other forms of energy such as light energy, sound energy, thermal energy, and mechanical energy. Power refers to the rate at which energy is supplied or converted by the appliance or circuit. It is the rate at which energy is lost or gained at any given location within the circuit. As such, the generic equation for power is P equals the change of E over T. The energy lost or gain is simply the product of the electric potential difference between 2 points and the quantity of charge which moves between those 2 points in a time period of T. As such, the energy lost or gain is simply the change of V times Q, which is the charge. When the expression is substituted into the above equation, the power equation becomes power equals the change of V times the charge over T. Since the charge over time ratio found in the above equation is equivalent to the current, the above equation can also be written as power equals the change of V times I. By combining the Ohm's law equation with the above equation, two other power equations can be generated. They are P equals I squared times R, or P equals the change of V squared over R. The standard metric unit of power is a watt. In terms of units, the watt is equivalent to an amp times volt, an amp squared times ohm, and a volt squared over ohm. The brightness of a bulb depends on the power dissipated by the bulb. Remember, power is given by any of the equations I squared times R, IV, or V squared over R. Okay, in a series, the current is not being shared, which means the light bulb gets the full power. But in a series, the voltage is being shared, which means as more light bulbs are added, the light becomes dimmer, and that's because the voltage is being shared.
If you connect a 9-volt battery to a light bulb, the brightness of the bulb will be higher than a light bulb connected to a 6-volt battery. That is because brightness is affected by voltage and current, since brightness is affected by power. Then, power equals current times voltage. The increase in voltage causes an increase in power, which causes higher brightness.
An important thing to remember about Ohm laws is that all quantities, the voltage, current, resistance, and power, must relate to each other in terms of the same points in the circuit. For instance, with a single battery, single resistor circuit, we could easily calculate any quantity because they all apply to the same 2 points in the circuit. Since points 1 and 2 are connected together with the wire, and points 3 and 4 are connected, we can say that point 1 is electrically common to point 2 and point 3 is electrically common to point 4. Since we know that we have a 6 volts of battery going through the circuit, we must also have 6 points going between 1 and 2 and 3 and 4. Therefore, we can apply Ohm's law to the current through the resistor because we know the voltage across the resistor and the resistance of the resistor. All the terms apply to the same 2 points in the circuit and to that of the same resistor, so we can use Ohm's law formula with no reservation.
Go. The circuit can be redrawn, simplifying the two parallel resistors to their equivalent resistance of 67 ohms. Then what's left is two resistors, 100 ohms and 67 ohms, in series with the 9-volt battery. Since series resistors take the same current through each by V equals IR, with I constant, the larger resistance takes the larger voltage. That's the 100 ohm resistor. Parallel resistors take the same voltage across each, equal to the voltage across the equivalent resistor. Ranking by voltage gives 100 ohms is bigger than 120 ohms, which is equal to 150 ohms. Current only runs through a wire. All the current in the circuit must run through the 100 ohm resistor and then split at the junction with the parallel resistors. The parallel resistors each take the same voltage. By V equals IR with constant V, the smaller resistor takes the larger current. That's the 120 ohm resistor. The ranking by current is 100 ohm is bigger than 120 ohms, which is bigger than 150 ohms.